we were saying the refraction through the combination of thin lenses which are in contact. So there is a two stages of image formation. First one is from first lens and second one is from second lens. In the first lens, see the refraction through the first lens. In this we are considering the only the first lens and we are taking the in absence of a second lens. Here the whatever the I1 here I1 will be the real image of the object O. Here O is the point object which is, and the real image distance is V1 and I1 is the real image formed from the first lens. And then by using a thin lens formula we will have 1 by V1 minus 1 by U is equal to 1 by F1. And next by diffraction through the second lens, here we are considering the only second lens. We are taking the equations in absence of a first lens. And in second lens, the incident ray, it is not coming from any real object. So whatever the image is formed, that is also a virtual image. And whatever the object is there, that is a virtual object. And by using a thin lens formula, we will have 1 by V minus 1 by V1 is equal to 1 by F2. By adding these two equations, we will get 1 by V minus 1 by U is equal to 1 divided by F1 plus 1 divided by F2. It says that the equivalent lens of a combination of lenses is that single lens which produces the same effect as the produced by a combination of lenses. Now we will consider a equivalent lens which forms the same image by a single lens which will be the combination of these two lenses. So when we will consider that equivalent lens which is having the F as a focal length, by using the thin lens formula we will have 1 by V minus 1 by U is equal to 1 divided by F. Now we will compare this equation and this equation. So we will get 1 by F is equal to 1 divided by F1 plus 1 divided by F2. Thus it says that the reciprocal of focal length of an equivalent lens, that is 1 by F, is equal to the sum of the reciprocals of the focal lengths of the lenses which are in contact. And this formula holds good for the only in case of a thin lenses in contact. And we know that the power of the lenses, so the power of the first lens is P1 is equal to 1 divided by F1 and power of the second lens is P2 is equal to 1 divided by F2. And if the power of the equivalent lens is P is equal to 1 divided by F, then we will have P is equal to P1 plus P2. By using the above equation we can say like that. That is, power of an equivalent lens is equal to the sum of the powers of individual lenses which are in contact. Now we will see the refraction through a prism. Prism means it is an optical medium which is having the 3 rectangular faces and 2 triangular faces which are parallel to each other. This image is the image, it is of a prism. Here it is consists of a C, A, B, E, D, and in that side also C, F, D, A and C, B, E, F. These are the rectangular surfaces which are in 3 number, and it consists of 2 triangular faces which is A, C, B and D, E, F. These are the 2 triangular surfaces. In these faces, in these 3 rectangular faces, there are 2 which are well polished, which are known as refracting faces, and the third one will be the less polished or it is not polished, and which face said as a base of the prism. The edge common to the two refracting faces is called a refracting angle edge, and the angle between them is known as a refracting angle of the prism or the angle of prism. See here, this ABED and ACFD are the refracting faces in this figure. AD is the refracting edge. This AD is the refracting edge, and the angle BAC is the angle of the prism, and BCFE is the base of the prism, and XYZ is the principal section of the prism. Now we will see the refractive index in terms of the angle of a prism and angle of a minimum deviation. See this ABC, consider a prism. This represents the principal section of a prism of a refractive index n, which is surrounded by air. Let A be the angle of the prism and BC be the base. This A is the angle and BC is the base of the prism, and a ray PQ incident on the prism with an angle making I, that is the incident angle, and the refraction takes place at a point Q, and next after refracting it will make at an angle R1, that is the refracting angle, and after this it will, that is R1, and after this it will make another refraction at a point R with an angle, incident angle R2, and after refraction it will make an angle I2. During the passage through the prism, the ray bends towards the base CRS. It is bended towards the base. Next, MQN and ORN are the normals to the faces AB and AC. MQN and ORN, these are the normal drawn at the point of incidence. And next, in the absence of a prism, the PQ would have travelled in a straight along like PQ teacher line. See, if the prism was not there, then this PQ line would have taken the path that is PQ teacher. So we will extend that line. The angle between the incident direction PQTZ and the emergent direction TRS is the angle of deviation, that is denoted by D, that is ZTR. ZTR is the angle of deviation D. Next, in the quadrilateral, consider AQNR. Consider this quadrilateral. In this, we can say that the angle AQN is equal to ARN, which are both are equal to the 90 degree. So, therefore, we can write the angle QAR plus the angle QNR equals to the 180 degree. And we know that QAR is the angle of the prism, which is denoted by A. So we have substituted in the place of QAR as A plus QNR is equal to 180 degree. Next, in the triangle QNR, this QNR, that is R1 plus R2 plus QNR angle, that is equal to 180 degree. Then by these equations we can say that the A is equal to R1 plus R2. That is, you have to substitute in the place of Q and R, substitute the value of Q and R which are derived from the triangle Q and R. That is equal to 180 degree minus R1 plus R2. Then substituting these equations, we will get A plus 180 minus R1 plus R2, that's equal to 180. Then the 180 degree and 180 degree get cancelled. A is equal to, we will get R1 plus R2. And next, now consider the angles ZTR. ZTR, which is equal to the angle TQR plus TRQ. Next, we know that ZTR is equal to D. In the place of ZTR, substitute D. Then next, TQR. We know that TQR is equal to I1 minus R1. That is, first incidence angle minus first refracted angle, plus TRQ. TRQ is the I2 minus R2. Next, we will get I1 plus I2 minus R1 plus R2. Then by equal, next substitute the value of R1 plus R2, that is equal to A. That is, then we will get D is equal to I1 plus I2 minus A. Then by this equation we can write that A plus D is equal to I1 plus I2. By this we can say that the angle of incidence increases from 0 degree when the angle of deviation decreases and reaches a minimum value, certain value D, and again it starts to increase as the angle of incidence increases. So this least deviation is called as the angle of minimum deviation and represented by the letter D, which is shown by this figure. And we have that for a given value of a deviation D, this D, we have two values of incidence, that is I1 and I2. And this is because the I1 and I2 values are interchangeable, because the path of the rays can be retraced. So at a minimum deviation position, these two angles are equal, and hence there is only one value for the angle of incidence at the minimum deviation position. So I1 is equal to I2, then we will have R1 is equal to R2. Next we will get, let's take I1 is equal to I2 is equal to I, and next R1 is equal to R2, that's equal to R. Then substitute these equations in the equation A, that is A is equal to R1 plus R2. We will get A is equal to 2R, that is R is equal to A by 2. Next, put the same in the A plus D equation. A plus D is equal to I plus I, that is A plus D is equal to 2I. At that time we will get I is equal to A plus D divided by 2. We got the R, we got the I. Next, by Snell's law, that is sin I n is equal to sin I by sin R. We will have sin of the A plus D divided by 2 whole divided by sin of A by 2. This expression, this above equation n is equal to, which gives the refractive index of a material of a prism is terms of angle of a prism and angle of minimum deviation. A thin prism or a small angle prism is one for which the refractive angle A is small, and in this case we will have n nearly equal to A plus D divided by 2 whole divided by A by 2. For an angle very much small, we have to neglect the signs. So we will get A plus D divided by 2, A plus D divided by A, or NA is equal to A plus D. Therefore we will get the D, that is the minimum deviation. D is equal to A into n minus 1. This is the angle of minimum deviation in terms of refractive index and the angle of the prism. Till now we have learned about refraction and refraction through the planes and by the spherical surfaces and lenses and by prisms. And in our day-to-day life also we have certain refracting phenomena. In that, rainbow is also one of the phenomena. When the sun rays passes through the raindrops, we will get there is a dispersion of that white light takes place, and because of that dispersion there is a visibility of rainbow, that is which is the having the 7 constituent colors. And this is the formation of a rainbow, which is one of the consequence of a refraction or a dispersion. And we have last, that is optical instruments. We have so many optical instruments. These optical instruments are the devices which help human eye in observation and detailed examination of the object. These devices and instruments are designed utilizing the reflecting and refracting properties of the mirror, lenses and prisms. These all the optical instruments are made up of the reflecting surfaces, refracting properties and mirrors, lenses, prisms and these only. And there are some optical instruments like microscopes, telescopes, periscopes, binoculars and so many. We will see the eye. Eye having the complex structure, like it is having the cornea, pupil, iris, eye lens, and it is also having the eye lens. And there are, which is essential for the vision of a human being, not only for a human being, for all living beings. The eye is essential, but it has some of the defects, and those are the myopia, that is short sightedness. That is, the myopia or short sightedness is that the defect of a human eye by virtue of which the eye can see clearly the objects lying near it but not the far objects. In myopia, what happens? The human eye cannot see the far objects. Only nearer objects can be visible. The far objects will not be visible. So, to overcome from this defect, we use concave lenses of a suitable focal length. And by using concave lens, we can overcome by this defect, that is myopia. And another one is hypermetropia or a long-sightedness. In this, we can see the far objects, but we cannot see the nearer objects. So in this state, we can use a convex lens, which is of having a suitable focal length. By using this, we can overcome by this defect of the eye. And another, some defects are there like astigmatism, presbyopia or old sight. Old sight means as the people get older, their muscles get weakens, and because of the weakened muscles, there is a defects comes to them by their old age. And by using certain lenses, we can adjust their defect also. And this is about the optics and optical instruments.